Today we're going to talk about points, lines, and planes as our introduction to geometry. These are three undefined terms in geometry. What that means is we learn about their attributes, but they don't really have a technical definition. They are the most basic form of geometry that all other geometry is built upon. You can think about it as your building blocks for geometry. Like letters in alphabet, like you have to know all the letters in the alphabet before you can actually start building words. So that's what I mean by they're undefined and everything's built on them. So the three are point, line, and plane. And a point has no dimensions. A line has one dimension, and we call that length. And the plane has two dimensions, length and width. You can also give it as length and height, or width and height. But typically people say length and width. So let's go through and talk about a line to start with. We are going to learn notation in this section, and you do need to know the exact notation. Here we have a picture of a line. This line can be referred to as line AB or line BA. Either one is fine. And notice that the notation has a line above it with arrows on both ends, and it does not have any points on it. So you have to use that exact notation when you're describing this picture of line AB. You can also use BA with the correct notation above it. One thing we do know about lines, even though we don't have a technical definition, is that through any two distinct points there is exactly one line. And that makes a lot of sense if you think about it. If you look at this picture right here, if I pick any 2 points, there is going to be a line that will go through it. There's no way that cannot happen. Our next definition is collinear. Collinear points are points that are on the same line. So, for example, we have point L and point O, and those are points that are on the same line. So L and O would be considered collinear. We have quite a few collinear points. So we're going to list just a couple of them. We have M and L, M, N, and O. So you can have several points that are collinear. We have L and N, and there may be some more that I haven't mentioned, but anytime you have 2 or more points that are on a line, those are considered collinear points. The next definition is line segment. And you guys know about line segments from elementary school, but you do need to know the proper notation. A line segment could be referred to forwards or backwards, so we could refer to this as segment AB or segment BA. And the notation is just a line over AB or a line over BA, no arrows on the ends and no points on the lines. Line segments have 2 endpoints. One thing we do know about lines is that lines extend forever in both directions, whereas line segments do stop. They are finite. So that's one difference between the two. Congruent means having equal measure or the same length. So, and the symbol is an equals mark with a similar symbol above it, or an equals mark with a squiggly. So when in geometry, when we're talking about that we have same lengths or same angle measurements, we use the congruent symbol. So if we are talking about line segment MN being congruent to line segment RS, here is our proper notation. We use the proper notation for line segment, and then we use the congruent symbol. So all of these symbols are very important. Midpoint creates 2 congruent line segments. So you can have a midpoint of a line segment. You cannot have a midpoint of a line because lines are infinite, and you can't measure 2 sides of something that's infinite. But if you have a line segment, you can split that line segment into 2 congruent parts. So, for example, in this picture, if we know that M is the point of line segment AB, then we can deduce that line segment AM is congruent to line segment MB. So here's a tip with notation. You want to use the congruent symbol to denote sets that are the same length. Use the equal symbol to show the actual length of the segment is. And we'll see more examples of that later. Also use the line segment notation with congruent and don't with equals. So here we have ray AB. That's our next definition. Ray AB notation has a line with the arrow on the right-hand side. The arrow always pointing towards the right. The first letter in your ray notation has to be the endpoint of the ray, regardless of which way the ray is pointing. So a ray has one endpoint and extends forever in one direction. So for example, in the picture, you could call this ray MN or MO. You would never use 3 letters to describe this ray. You have to include the M because that's the end point, and it must be the first letter in your notation. Again, the arrow has to point to the right even though in the picture it's pointing towards the left. Here we have line AC, and in line AC it has line segments and rays that are part of the line. We could look at all the different parts of this line. So I have all the different notations written here that we could see when we were looking at this particular figure. So line AC or line CA could be made up of line segment AB, line segment BC, line segment AC, line segment BA, line segment CB, line segment CA. We could also see in this figure ray AB, ray BC, ray AC, ray CA, going the other way, ray CB, and ray BA. So we're going to do a little bit of math here. So in this picture we're told that we have line segment CD and M is the midpoint. So we know that CM is congruent to MD. So we're told that CM has a measure of 6. And we're asked to find CD. So we're looking for this entire length. And that should be pretty easy because we know that X is going to be twice as long as CM. So 2 times 6 is 12. So the line segment CD is 12 since half of it is 6. In our next problem, we're told that CD equals 15. So now we know this whole thing is 15. And we're asked to find MD. And we know that's going to be half the measure of 15. So MD equals 1/2 of 15, which is 7.5. Now notice here we are giving the exact measure for these line segments. And so this goes back to the notation I was referring to earlier. When you give exact measures of line segments, you don't include the line segment symbol that goes above it, and you use an equals instead of a congruency symbol. So that's what the notation looks like when you are working with exact measurements. In our next slide, we're going to do some more complicated math where we have to actually throw in some algebra. Here we have line segment CD with the M as the midpoint, and we're told that CD is 4x. So this whole line segment has a length of 4x. And CM is 8. Well, if that's 8, then the other side has to be 8. Line segment MD has to be 8 because we know those two are congruent. So you could kind of approach this from a couple of ways. You could say 2 times 8 equals 4x. You could say 8 equals 1/2 of 4x. You could say 8 plus 8 equals 4x. Any of those are fine. So 16 equals 4x. We're going to divide both sides by 4. And x equals 4. And we can double check that and see if it makes sense. 4 times 4 is 16. 8 plus 8 is 16. Works. So we know we did it correctly. In the next problem, we're told that CM is 10x and CD equals 10x plus 20. And we're asked to find x. Now we can approach this a couple of different ways. So what I'm going to do is I'm just going to double 10x because I know this side is 10x, so this side over here equals 10x. There are other ways you could approach it. You could say, well, if this is 10x plus 20, you know that's 10x, and this has to be 20. You could work with that. But let's just do 10x plus 20 equals 10x plus 10x. So 10x plus 20 equals 10x doubled, or 10x plus 10x. So 10x plus 20 equals 20x. I'm going to subtract 10x from both sides so that I can get all the x's on one side. So we get 20 equals 10x. We're going to divide both sides by 10, and x equals 2. And I can double check this. So if I put 2 in the place of x, here I'd get 20 plus 20, which is 40. And if I put 2 in the place of x here, I'd get 20. Same thing here, and that does equal 40. So I did it correctly. And our last problem like this, we are, again, have the midpoint. So CM is 18. MD is 4x minus 2. Now, think about, what do we know about CM and MD? We know that they're congruent, or equal to each other. So we can set those equal to each other. 18 equals 4x minus 2. I'm going to add 2 to both sides. So I end up with 20 equaling 4x. Divide both sides by 4 to get x by itself, and x equals 5. And I can check. 4 times 5 is 20, minus 2 does equal 18, and those two sides are congruent. So moving on to our next topic, we're going to talk about a plane. A plane extends infinitely in all directions. So it's kind of like a parallelogram, except it doesn't really have any sides. It just goes on forever. You could think about the wall of your classroom if it was to go up forever, down forever, and to the left and right forever. And one of the things we know about a plane is that if we have 3 non-collinear points, there is exactly one plane. And the reason for this is when you have 2 points, you're going to be able to draw a line through it. Any 2 points. We learned that earlier when we were talking about the properties of a line. But as soon as you put in a point that is not on that line, there's no way that all 3 points can be collinear. And what this does is it creates a third dimension. We're going from just length to now length and width. And so as soon as we go from length to length and width and it's infinite, that's a plane. So we have a picture down here and a website to look at. Coplanar means exists on one plane. So in this picture down here we have plane R and plane P. Plane P is the yellow plane, plane R is the blue plane. The 2 planes are intersecting. Now this parallelogram ABCD is on plane P. This parallelogram PQRS is on plane P. The 2 parallelograms are coplanar. Any points that we put on this plane will be coplanar, as long as they're not collinear. The 2 planes themselves